What are some terms we've used and learned that I could use to say what these are? What is lithium? What is sodium? What is potassium? What are rubidium?
Elements.
They are elements, and elements are different types of what? Elements are different types of what?
Chemicals.
They are, but what is the word we've learned for it? Elements are different types of what? What are we studying? There we go, Brighton. Atoms. These are different types of atoms. Lithium atom, sodium atom, potassium atom, rubidium atom. So what do you think the size of the circle represents? Okay, it is partially its mass, but if Brighton, if these are individual atoms, what does the size of the circle represent? Okay, as the mass goes up, what also goes up in the atom? As the mass gets larger, what also increases? The number of protons and neutrons. And if the number of protons increase, that also means the number of what increases?
Electrons.
Electrons, very good. And are electrons all in one place around the nucleus? They're spread out, good. So now try this again. What does the size of the circle represent? It represents the size of something. The size of what? The size of the circle on the cards represents the size of the what?
Atomic weight.
Nope. Ah, Brighton, there we go. The rings, Anaya, how big the atom is, right? If it has more electrons, it's going to have more rings. If it has more rings, doesn't that mean that the atom's going to be bigger? Okay, so as the atomic weight increases, the size of the circles increase because the size of the atom increases. So rubidium atoms are much bigger than lithium atoms, okay? Potassium atoms are much bigger than sodium atoms, okay? All right. So now let's go look at the next chunk of questions, right? These kind of came in chunks of 3. So now we're looking at the group for magnesium. And again, the goal here in this homework assignment was to answer these questions based off the card sort. Once again, I have shared this proper card sort with you so that you have the correct answers. You just need to make sure to find it in your email. So here is my slide sorted with magnesium. And the elements that I see sorted with magnesium are calcium, beryllium, and strontium. Okay, what properties do these have in common? What characteristics or properties do these 4 elements or atoms have in common?
What was your question?
All right, good, Anaya, they're all metals. What characteristics do these cards have in common?
The same color.
All right, so what color are they? Yellow, good, Jaden. What else is common? What else do they share? They're metal, they're yellow.
They have the 2 at the end of like the SRCL, and then they have a 2 there.
So a couple good observations. They have 2 sticks, but then if you look in the bottom right corner where it says like found in and it names a compound, there's a 2 behind all of them. Very good. And the reactivity here all involves reacting with what?
Water.
Water. Okay, great. So if I were to line these up, what would I put on the far left side?
Strontium.
I'm sorry, what?
Strontium. Wait, is that what it's called?
Strontium, but you're close.
Oh, okay.
Right, what would I put next?
Calcium.
Okay,
Then magnesium
okay.
and calcium.
And then beryllium?
Oh, yeah, so it's called that, yeah.
Right. So if I look at it this way, okay, I can see what we just did, right? The atomic weight is getting smaller. So strontium is the heaviest atom here, then calcium, then magnesium, and then beryllium. And remember, the size of the circle represents what again? Size of the circle represents what?
The outer rings.
The outer ring. So how big the atom is, right? So strontium has most rings and is the biggest. Beryllium has the fewest rings and is the smallest. All right, if I look at reactivity, let's see if I can make some connections here with reactivity. So strontium is huge and has a really heavy weight, okay? And it says it reacts vigorously with water. Beryllium is tiny and has a small weight and it doesn't react with water. So for these ones, as the weight gets larger and the atom gets larger, what happens to its reactivity? Is it more or less reactive as it gets bigger?
More reactive?
More reactive, very good. Okay, so now let's look at our next set here. Our next group of elements for number 9, 10, and 11 are the ones with indium. Indium is kind of a pretty name, huh? All right, so here are elements. So we should have said that the other elements we grouped with indium were Ga, gallium, B for boron, and Al for aluminum. Characteristics I see here again, metals. They're all metals. They all have the same color, which is this kind of light lime green. They all have 3 sticks, and their reactivity all mentions oxygen. Okay, if I were to sort these, who could tell me how to sort these? What order would I list them out in?
From lightest to darkest.
Okay, so I could go lightest to darkest. So which one is the lightest?
Boron.
Okay, what would go next?
Gallium.
What would go next?
Then aluminum and aluminum of that.
Okay, and then what would go at the end?
Indium.
Right, does everyone agree with this order?
Gallium and aluminum should be switched.
Ah, gallium and aluminum should be switched. And what do you use to figure that out? Because they do.
Atomic weight numbers.
Because the atomic weight numbers, those decimal numbers in the circles, because their shapes are pretty similar, so that could be difficult to distinguish, okay? So again, we could use their weight. So here, for this group of atoms or elements, it's going from the lightest to the heaviest on the right, and the heavier it gets, the bigger it gets, because it has more protons, neutrons, and electrons. Let's look at the reactivity, if that matches, right? In the last group, we said the heavier and bigger it got, the more reactive it got. So doesn't react, doesn't react, doesn't react, react slowly. So yeah, as it gets bigger and heavier, it becomes more reactive. All right. Let's look at our next group here. So this would be for 12, 13, and 14. We're looking at the tiny little group that is carbon. Oh my God, this little group. So the only other element we had here with carbon is silicone. They're both slightly darker green. They have 4 sticks. They are both metalloids. And their reactivity both has to do with oxygen. Okay, so for this one, I could do light to dark or by the weight. So this is the lightest and smallest atom of the 2, and this is bigger and heavier of the 2. And we can also see that reactivity still holds true, right? Does not react with oxygen, reacts slowly with oxygen. So when it's a little bit bigger and heavier, it's more reactive, okay? And again, everything we've talked about so far were metals, and this group are metalloids. All right, so now we're gonna move on to number 15, 16, and 17 with phosphorus. Okay. So phosphorus should have been grouped together with arsenic, nitrogen, and antimony. What do these four elements or atoms have in common? What do these have in common?
They all have something in common with oxygen besides nitrogen.
Okay, so the reactivity kind of revolves around oxygen. Good. What else?
Two of them are nonmetals and the other two are metalloids.
Okay, so two are nonmetals, two are metalloids. So that might have made it a little bit difficult to group them. If I look at the cards, the amount of sticks they have, good. So they all have 5 sticks. And then they all have the same kind of like robin egg blue color, okay? So if I were to put these in order, what order do we think I should put these in?
Darkest to lightest.
All right, darkest to lightest. So what would go first?
Antimony, antimony. Is that what it's called? Antimony.
All right. So you're saying that's the darkest?
Yes.
Okay. And then what would go next?
Phosphorus.
Okay. What will go next?
Arsenic.
And then,
Nitrogen.
okay, do we all agree with this?
Arsenic and the other one should be switched again.
Arsenic and phosphorus should be switched. Okay, so if we look at the atomic weight, do we now see that the atomic weight now kind of line up in a sequence from big to small? Okay. So here for these, again, these say metalloids and non-metals, okay? So nitrogen is smaller and lighter, does not very reactive, period. Phosphorus and arsenic. Phosphorus does not react with oxygen. Arsenic slowly reacts with oxygen. So a little bit of an increase, but not quite as extreme as we saw in our metals, right? Our metals, when they were big and heavy, they were vigorously reactive, explosively reactive. Here, I mean, something happens kind of slowly, but not much, okay? All right. Next group of characteristics here would be 18, 19, and 20. So the group with tellurium. All right, so here's my group with tellurium. What do these all have in common?
They're all black, I think purple or blue.
Very good. They're all this kind of like darker speckled blue. Okay, what else?
Like a dash of blue. But yeah. I noticed that all that are found in like H2O gases or H2SE, TE gases.
Good. So they all form things that are gases or the liquid.
And they all react slowly with metals.
React slowly with metals. Good. What about the sticks they have? How many sticks do they all have?
Oh yeah, let's see. They all have 6 sticks.
Very good. So again, if you want to sequence these from lightest to heaviest or heaviest to lightest, so oxygen atoms have a mass of about 60, about 32. Then we have selenium, and then we have tellurium. Okay. Now, also when I look at this, right, selenium and tellurium are my bigger atoms of this group. And let's look at it. Did the reactivity really change at all here? As it got bigger and heavier, did the reactivity change?
No.
No. Okay. So that's different than what we had been seeing in other cards. Okay. And important for us to keep in mind. All right. Number 2122, fluorine. Okay. So here's our group with fluorine. I notice they're all nonmetals. They all mention reactivity with metals. They all form gases. Okay, so if I were to line these up, kind of like how we have been. All right. What happens here with the reactivity? So as it gets bigger, does it become more reactive? As these nonmetals get bigger and heavier, does it become more reactive? Anaya said no, and that's correct, right? Look at the big ones, it reacts, but as it actually gets smaller and lighter, it becomes more reactive. So now we can see, right, if it's a nonmetal, if it's smaller and lighter, it is more reactive. Whereas if it was a metal, if it's bigger and heavier, then it's more reactive. Okay, we have one more group to look at here, and it is here with our noble gases. What do we notice here? They're all unreactive. Okay, are they a metal or non-metal?
Non-metal.
All non-metals. Okay, very good. How many sticks do they have? Are they all the same?
No, some of them have like 8, and there's one that has 2.
Okay, so one has 2 and some have 8. So that's an important thing for us to think about here as we move in today's assignment, because you're going to figure out what these sticks represent. I really kind of have to smash them together here, so give me a second. Ooh, little baby helium. Okay, I can still sort them by mass. Just kind of have to resize them a little bit to get everything to kind of fit nicely, kind of nicely. Okay. So we can see here, right? They have the largest number of sticks. They're all nonmetals. They're all completely unreactive. So it didn't matter what their size or weight was in this group. Okay, so that is interesting. I at least think that's interesting. Okay, so again, I did send everyone an email that got this. I know that people got it because they opened it. But there again is the link. And now we need to look at what your homework assignment is for today. Okay. So we're going to click a couple pages here in Canvas. We just went over your homework assignment from Monday. And now your homework today is the 11.8 assignment, decimal numbers and sticks. Okay. So here's what the assignment looks like when you open it. Similarly, you have a list of questions here. These questions are also based off the card sort that we've been using. So you need to make sure to use the correct card sort. Your job again is to look at your card sort, and you're also going to use a periodic table. And you are to kind of try and figure out what different things on the cards now represent. So specifically, what the decimal numbers and sticks represent. Today's assignment is a little bit more challenging because some of the questions like number 5 ask you to figure out on your own what the sticks represent. And in order to figure out what the sticks represent, you actually are going to have to draw some atoms. So number 5 tells you to, on a scratch piece of paper, draw an atom of beryllium and an atom of boron. Then look at how many sticks they have coming out of the circles and try and figure out what you think the sticks represent. Okay. Once you figure out that, you'll need that answer to answer questions following that. Okay. So today's homework is really relying on you to connect and apply what we've already learned about atomic structure, atomic weight, atomic number, to make sense of the rest of the information on the cards. Okay. So today's homework assignment, while it is shorter, is more challenging, okay? This homework assignment is going to be due tomorrow night, okay? So not Friday, tomorrow night. You have the remainder of class today, so that's gonna give you about 35 minutes to start working on it. And as you have questions, like always, make sure that you drop them in the chat and let me know so that I can help you out as much as possible. Okay, does anyone have any questions about what your homework is, when it's due, anything along these lines? Okay, then you guys can start working on your homework. And again, the moment you have a question, make sure you drop it in the chat and let me know so that I can help you.